Hello, everyone. Good morning, good afternoon, depending on the time zone where you are right now. Hello, Nikita. Nice to see you. Your mic is turned off, by the way.
Yes. Hi. Hello, everybody.
Okay, hi. There's many people joining right now. Um, so yeah, pretty excited to hear what you have to say about the hallmarks of aging.
Yes. Hello,
So
everybody.
yeah.
Yes.
Yes. So the way it's going to work, right now I have to click a lot of times to add everyone and to accept everyone in the room. So what I'm going to do, so it's going to happen during 1 hour. I'm going to introduce the iCare longevity community for 5 minutes and the context of what we are doing, what we are trying to achieve here. And then I will let you introduce yourself, Nikita, and also talk about the topic that you have decided today for 30 minutes. And then we would have 30 minutes of questions and answers. Just for everyone to know, this conference is recorded. And we will share this with many other community members that unfortunately have not been able to attend in real time today because of time zones or busy schedules. But there's a bunch of them who watch those replays and still take a lot of value out of these meetings. Okay, so this being said, I'm going to start the short presentation of iCare Longevity. And this will leave some space, some additional minutes for the people who are a little bit late to join. So let me start by sharing my screen. And here we go. Okay, share. Okay, so a little bit about iCare Longevity. So iCare Longevity is the first community of people who aim at living 100 years in good health and act upon it. As some of you know, and others should discover this as soon as possible, um, a couple of years ago, science have moved forward with longevity and the prospect of living longer and healthier. And today, living 100 years in good health is no longer a pipe dream. It's an ambitious yet attainable goal. And this is what we are after at iCare Longevity. So what we do is those workshops that we organize on a biweekly basis are supposed to offer 100% free practical insights into longevity so that people become aware of the science behind it, how preventative medicine is changing the way we take care of our health, and tips and tricks, practical tips and tricks, and do-it-yourself things that we can do in order to improve our health. That's the okay. That's the goal of iCare Longevity, and we have a community. We have a Slack workspace and a lot of resources to help again people who are curious about this and who are just discovering this and want to know more about this, and also again catch some practical strategies to apply in their daily lives. Now, for the people who want to go further and get serious about taking care of their health in preventative mode, we have also a service which is called iCare.ai, where we pair a medical doctor with expertise in longevity and a health coach with expertise in longevity also, with each one of our patients in order to create a personalized program for each one of our patients to help them live longer and healthier with preventative medicine, with diagnostics, with lifestyle recommendations, and so on. So, this being said, let's get to the topic today. So we have Nikita Naik or Naik. Please correct me if I'm misspelling your name or mispronouncing it. Who is a scientist in genetic manipulation and molecular cell biology. She's author of multiple publications in the field of geroscience, and still people coming, which is exciting, but interrupt me in the presentation. So yes, and she's doing a lot of additional very interesting stuff, but I think she will be a better person to introduce herself. And she's going to talk about the 12 hallmarks of aging, which are 12 very interesting mechanisms which explain why we are aging at the biological level. Wow, yet new people. Okay, so Nikita, the floor is yours. I'm going to stop sharing my screen, and you will be able to share your presentation if you have any.
Hello, everyone. I'm Nikita Naik. I'm a scientist at Akashta Health. It's a health tech biotech in India. So we study aging and aging-related conditions. So since this talk is exclusively about practical tips, in the beginning, I'll talk a little bit about hallmarks of aging. I will not go in detail on all the hallmarks because then it will be a lot. And then I'll move on to the science-backed recommendations on how to deal with aging. So, as first of all, I would like to thank Gabriel for giving me this opportunity to talk about this and to making me involved in such an amazing community. Thank you.
You're welcome, Nikita. Excited to have you on board.
Yeah. So, before I begin, I would like to ask you, what comes in your mind when you think of the word aging? Anybody? Aging. Just one word. You can tell me what's the first thing that comes in your mind? Yes?
Disease.
Okay. And
Oh,
prevention.
prevention. Oh,
Yes.
that's new. And
Death.
rest. Okay.
No, death.
Death.
Test. Lots of tests. Okay. Anybody else?
Capacity.
Cell deterioration, capacity. Very good. So all of this, basically, it's all these words that you mentioned, they have a negative connotation, right? You think of all the negative things like tiredness, like when you mention capacity, reduction of your capacity, and the number of tests that you have to do. So when you think of aging, what usually comes in your mind is, wisdom. That's positive as well, wisdom, and then weakness and frailty. Because when aging has been traditionally seen as an inevitable decline, but imagine you could slow down or even reverse aspects of aging. What if I told you that science is uncovering ways to do exactly that? So recent advancement reveal that aging is not merely an unavoidable process. It's a condition with identifiable and potentially modifiable symptoms, right? So a condition is a group of symptoms. If you can deal with each of the symptoms, maybe you won't be able to just get rid of the condition, but still you would be able to increase, the quality of life. That's what you do when you are suffering from a condition. For example, diabetes is a condition, right? You try to deal with the symptoms to improve your quality of life. So we have to change our perspective and look at aging the same way. Because why does it matter? Because aging is not just getting old. Like someone mentioned that, capacity and tests and also diseases. It's because aging is the biggest risk factor for many diseases like cancer, heart disease, dementia. And unlike these diseases, which are studied and treated, aging has not been yet. But nowadays, we are studying aging and learning that it's not a disease, but it's a condition which you can treat if you understand it well. So to understand aging, and before I go into understanding aging, I would like to use a simple analogy of cancer. Aging is like cancer. Cancer starts when cells stop following rules, leading to uncontrolled growth. We all know that this is the end point of cancer. Regardless of what caused it, this is what happens in cancer. It leads to uncontrolled growth. Similarly, or actually quite opposite, aging starts when cells start losing their function, leading to decline. And eventually the cells start to die. So when the cells of your major organ starts to die, that is what you call, aging and then death. So just like we study and treat cancer, we can now study and treat aging to improve health span. So health span, lifespan, we all know. Lifespan is the number of years you are alive. Health span is the number of years you're healthy. So we have extended lifespan in last couple of decades significantly from like 50 to 80. But now we are focusing on expanding, enhancing our health span. What's the point of living so long if you're not healthy and living the best life you can, right? So for that, we need to understand aging. And in all biological things, you have underlying mechanisms, right? Phenomena, you have underlying mechanism. But aging is so complex that experts have long debated a single underlying cause for aging, but instead they've reached a consensus that there are multiple causes. And these causes, mechanisms, they have called hallmarks of aging. So today we have 12 hallmarks of aging, but as we study this, we are uncovering new hallmarks. And each of these hallmarks represent a measurable aspect of the process that can guide targeted interventions and support healthier, more resilient aging. By leveraging these hallmarks, we can gain critical insights into an individual's health trajectory, allowing us to proactively program health to counteract age-related decline and promote healthy aging. Now, why do we need to understand all of these hallmarks and how can we program this? That's what I'll talk about. Because there's so many underlying mechanisms, each aging process of each individual is very unique because it can be a combination of this mechanism to different, variation. So one of this hallmark can be significantly involved in your aging process, and there can be like only 10%. So to understand all of this, we need to understand that's why your aging process is very unique. So what is aging, right? Aging is not just getting old. Just like I mentioned, it's a biological process driven by damage, dysfunction, and wear over time. Aging begins at cellular level long before we see wrinkles and gray hair. But if you look around you, you would notice that some people age much faster than others. And most of the time, we just, give credit to genetics, especially the ethnic genetic. Like, for example, Asians, we can visibly see that they age slower than other people, right? And genetics does play a role, but there are other things like lifestyle, environment, and many different things, but these are just general things. But the good news is you have control over many of these factors. Because it's such a complex condition, there are hundreds of factors involved, and many of these factors you can actually control. And if you can monitor and control some of this factor, you can delay or prevent aging-related conditions and enhance your health span. So moving on to the hallmarks of aging, to understand these hallmarks, think of your body as a high-performing car. And each of this, over time, wear and tear affect different parts. Similarly, over time, this hallmarks can be used compared to different defects in aging high performance car. So to start with, I'll start with the most studied one, the most commonly talked about, genetic instability. So this hallmark can be compared to faulty engine wires. So to talk about this, I had to talk about cell division. As I mentioned in the beginning, that actually happens when the cells stop dividing. Once they stop dividing, they just die. So before that happens, during its lifespan, it divides multiple times. Different cells have fixed number of times it can divide. For example, skin cells, it divides much faster than compared to your heart muscle cells, right? That's why you see visible aging in your skin much faster than you see effects on your heart. So when the cells divide, regardless of what kind of cells they are, they accumulate different types of DNA damage. In the beginning, it's very minute, negligible, and there are mechanisms that can deal with it. But as they accumulate, those repair mechanisms are not as effective to deal with them. And when they accumulate, they cause DNA damage, which leads to error in cell function. So that's why it's called genetic instability, because DNA makes up your genetic makeup. And when this instability happens, so just like faulty engine wiring, it's a very important part of your car. If that is faulty, then your car won't work or it will cause more problems. Similarly, genetic instability causes more different problems. And it's also highly involved in cancer. Actually, most of the disorders, it's highly involved. That's why it's the first hallmarks of aging. And also that is one of the reasons why as you age, the risk of you having cancer, being diagnosed with cancer increases. So moving on to the next one, this is telomere shortening. So if you are interested in the field of aging, you would have heard the term telomere. So what telomere is it's a protective cap on chromosome. Chromosome is the tightly bound DNA. So this cap, how does it protect? It protects it maintains the integrity of your DNA. So every time the cells divide, this cap reduces in length, just like tires. Every time you use your car, your tires wear out little by little. So by all means, you can say that, if you want to simplify, you can say that the length of this telomere can determine how many times this cell can divide now. Like if you know the length now, you can tell how many times it can divide further before it stops dividing. That's why telomere is studied by everybody in aging field. And you'll find many companies out there talking about telomere length because it's quantifiable and there's so much extensively studies done on it. So we know what are the different things that can be done to maintain the length of telomere. That is the good news. And there's also an enzyme called telomerase, which protects this protective cap, which protects the telomere from shortening. So we have different ways to help maintain the telomere. We can target the telomerase, we can target the different factors that affect the telomere length. So I'll talk about it more in the end of the talk when I'm talking about recommendations. So the next one, the third hallmark of aging that I would like to talk about is epigenetic changes. So you get your genetic makeup from your parents. It's hereditary. But then during your lifetime, there are small changes in your genetic makeup. And these changes are called epigenetic changes. What it does, it affects the gene expression, which is basically the protein that are produced based on this genetic makeup, and which can then speed up aging. And epigenetic changes happen mostly because of your environment, the kind of food you eat, the different types of physical, mental stresses that your body is going through, and the kind of different types of factors that you are exposed to. And this can also be passed on to your children. Some of it, not all of it. So, but that plays a significant role in the aging process, because as it is dependent mostly on the environment, based on the environment, it can accumulate. This accumulation speed is based on your environment, and then it can speed up your aging process. So since I talked about the protein expression, the next one is connected to that one. The next hallmark, most of these hallmarks are connected to each other. So next hallmark is loss of proteostasis. Before I talk more about it, I would like to reiterate that hallmarks are the underlying causes of aging. One of it, or all of it, or any of it can be the cause of your aging process. Can be a different combination. But these are different processes interconnected to each other. So loss of proteostasis. Proteo is protein and stasis is maintaining. So the process of proteostasis is like a cycle. You have production of protein, gene expression, and then those protein need to fold. It's a 3D structure. So based on the structure, the functions are determined based on the structure and genetic makeup. So if they are not folded properly, then they will not function properly, right? So we have mechanisms in our cell to degrade those proteins, misfolded one. And then the raw material is used again to make new proteins. So as the cells divide, those mechanisms slow down. And slowly, these misfolded proteins start accumulating. These are like, I have to go back to the car analogy, then it will be like a clogged fuel wire. So if the fuel wire is clogged, you won't get the fuel and the car won't function properly. So similarly, when these misfolded proteins aggregate, cells won't function properly. And there are many conditions associated with aging that are caused because of this reason. And one of the most studied one is Alzheimer's. So one of the main underlying causes of Alzheimer is accumulation of one particular protein, misfolded one particular protein in your brain that leads to Alzheimer's. And these hallmarks also give us, with the insight of what is happening, it also tells us what to target. Now, because we know that misfolding of this protein is causing Alzheimer's, there are many companies that are working on how to prevent this misfolding or assist the proper folding of this protein to, prevent Alzheimer's. If you know that you are predisposed to it, then you can look into it, and then they will see if you have aggregation, and then they're working on molecules that can prevent the misfolding. So that is one of the way to use these hallmarks. Next one is dysfunctional mitochondria. This can be considered as weak battery because mitochondria is the powerhouse of cell. It produces the energy currency, which is ATP. So mitochondria, just like cells, it divides multiple times. And down the line, its function starts declining. The energy produced starts declining. And that's why as you grow older, you feel fatigue all the time. And it can also lead to different types of diseases. Because when you don't have enough energy, when your body, different organs don't have enough energy to function properly, that can lead to different kinds of diseases. So I will also talk about mitochondria, I can say now. So there are recently, in last couple of years, scientists have started working on how to deal with this. So a couple of weeks ago, I read about a paper where they are studying if you can transfer mitochondria in your body, just like how we inject insulin, we produce artificially and then you inject, right? So similarly, if you can isolate mitochondria, which matches you, and transfer it in your body, I'm sure they started because of while they were studying different kinds of diseases related to mitochondria. But then in science, when you're working on a certain particular disease, you get some basic understanding which can be helped applied to something else because everything is connected to each other. So, and there are many other ways you can deal with it. There are some supplements, energy supplements like NMN. So NMN is a precursor of another energy molecule called NAD+. So by taking NMN, if you require, not everybody should, by taking NMN, you can assist mitochondria in the process by giving the precursors. So you're basically making its work less so it can, make up the target. So, okay, moving on to the next one. Cellular senescence. It's like when cells die, it's replaced by the new ones, right? But those dead cells, just like misfolded proteins, those dead cells need to be cleaned out. They need to be degraded and the raw materials need to be used for the new cells. But as the cells, sometimes what happens, these old non-functional cells stick around and they cause inflammation because cells are much bigger than your misfolded protein. So it won't just clog your fuel line. It will cause much more damage and thus causing inflammation. So, and like, for example, on your skin, dead cells, you can just exfoliate and remove them. But inside your body, you can't do that, right? So this hallmark is like broken sensors. The sensors that are supposed to detect these old cells and degrade them, they're not working properly. So these old cells, they accumulate and cause inflammation and other inflammation-related conditions. Next one I'll talk about is stem cell exhaustion. Stem cells are like spare parts. They can function as anything. So their main role in a grown human being would be to repair and regenerate. Wherever their need is there, they can go in that region and become cells that are required over there. They can become anything. But when they do this multiple times, even though they're supposed to be limitless, they get exhausted. And you have fewer and fewer number of stem cells available. So because of that, your repair and regeneration slows down. For example, if I want to compare this with an organ, liver. Liver is an organ that regenerates by itself, right? That's why if you want to donate a liver, you can donate a piece of your liver and it will grow back. Literally, even if you're donating this massive piece of liver, the whole thing will grow back. But if it is functioning a lot throughout its lifetime, for example, if you drink a lot, or if you take something toxic that liver needs to clean out, then the regeneration capacity of that liver, even though it's supposed to regenerate endlessly, it reduces because it's exhausted, right? Everything needs rest. So instead of acting like, then it becomes limited spare parts, thus limiting the function of your car because you don't have enough spare parts. And the last one I'll talk about is altered cell communication. This can be compared to a faulty GPS. Same types of cell within an organ or different types of cells, they interact with each other all the time. That is how they make sure a complex organism is functioning. And there are so many different types of biochemical reaction that is happening and everything just needed is there. But as the cells divide and they get older, sometimes there's miscommunication. And this miscommunication can cause multiple diseases and chronic inflammation. And to give an example, one of the conditions that can be caused because of this miscommunication is autoimmune disorders. So what happens over there is your cell is misidentifying your own cell as a foreign object and tries to kill it. So that's why it's fighting against itself. That's because of a miscommunication. So there are a couple other hallmarks, but I'll stop here talking about hallmarks. And these hallmarks, they drive aging, but they also provide targets for slowing it down. And these targets are called biomarkers. So bio as in biological markers. in a racetrack, you have markers to measure the distance, right? It is giving you a quantifiable information. Similarly, we have many biomarkers that gives us quantifiable information about this different hallmarks. Some of the biomarkers tell us only about one hallmark. Some tells us about a lot, which are much more complex, but easier to target, right? Because it's considering a lot of things. So I'll talk about just one biomarker, so it's easier to understand, which is telomere length. The second hallmark that I mentioned about was telomere shortening. So telomere length is basically just a length, a number. It gives you a number. And just like when you're measuring distance, you have a unit unit of measurements, meters. Similarly, you have here the unit of measurements is base pair. So it will tell you exactly, like for example, 10,000 base pair. That's the length of your telomere. So it's just these numbers are much higher, but I'm just giving an example. So if you know that telomere length will tell you where you are in your aging process. And if your telomere length is significantly less than it should be for your age group, then you know to focus on that particular aspect. And then you can have a specific recommendation plan to focus on your telomere length and check it again to see if that recommendation plan is working, maybe in 6 months or 1 year. And based on that, so it's basically giving you a quantifiable way to monitor whether that recommendation plan is working or not. And that way you can customize your recommendation plan. This is one of the simple biomarkers, but widely used because we have so much information and it can be customized easily. But so biomarkers give you, one thing is quantifiable. Second thing, it gives you insights on your aging process, which can guide your recommendation plan, as I mentioned. And so how is science reprogramming health and aging? So all this that I was talking about, this aging process, it's called biological aging process, because that is how your body is aging. And then you have chronological age, which is your calendar years, how long it's been since you were born. And just like a fitness tracker measures steps, and then it tells you how many calories you have burned, how many kilometers distance you have covered, your heart rate. Similarly, there are tools that measure this biological age based on these hallmarks. And there are tests like DNA methylation, telomere length, and different metabolic markers that give insight. And so if you ask me, I would say that most of these tests are genetic. So, and there are some metabolic biomarkers as well, but mostly they focus on genetics, because it gives us so much information that we understand and we know how to analyze. But aging is much more complex. So we have to consider genetic, proteomic, and then functional, clinical. We have to consider as many factors that we understand plays role in aging to measure your biological age. When you do that, it gives you more wholesome, holistic perspective of your aging process, so that the recommendation plan that you get based on those things will be more personalized to you. And then the adjustment will be less. And the more you understand throughout all of this, regardless of whether you do this or not, throughout all of this, you have to always listen to your body. And you have to listen to your body, because some of the plans might work for someone else, it might not work for you. Like, for example, I'll give you some general recommendation and I can tell you why it might work for some and why it might not. So these are all evidence-based strategies, and yet it might not work for everybody. For example, nutrition, fasting, Mediterranean diet, and protein balance for longevity. Fasting might not work for everybody. For example, if you're diabetic, if you have any other metabolic condition or digestive issues, fasting might not work for you, right? And so you need to know what works for you. For that, you need to know your body. Mediterranean diet, it's it should work for everybody, but it depends on the kind of lifestyle you're living, right? Whether you have kind of factors that you are exposed to. And then protein balance. So, and it also depends on your age. This methods might work for someone in their 40s, but it might not work for someone in their 70s. So you need to see protein balance. Protein is always recommended. It's in having a proper diet. Holistic diet is always recommended, but some of the proteins might be difficult to digest for some people. And some of the proteins, like I mentioned before, that telomerase is an enzyme, right? It helps. It's also a type of protein. So some of these enzymes, they help in digesting of different proteins. For example, lactose intolerance. So if you have lactose intolerance, you can't take dairy-based proteins because the enzyme required to digest it, you don't have it. So there are many enzymes like that which digest different types of protein. So you need to know whether you can digest a certain type of protein or not. And if you, there are some extreme cases where a lack of enzyme can cause life-threatening diseases. If you if you take that particular protein, something called phenyl. I can't remember the particular name, but it basically causes loads of kidney issues because you lack that enzyme. And then that protein doesn't digest completely, it goes and settles in your kidney. There are many metabolic conditions. As I mentioned, you need to know about your metabolic conditions. And the exercise, obviously, strength training. In our last talk that I had the privilege of attending, we talked a lot about exercising. Strength training is recommended for everybody. It's always better to start early before you start getting osteoporosis. Osteoporosis, everybody has that. It's not diagnosed because your bones do get porous as you grow old, but it depends on different people, how the extent of porosity. So it's always better to have strong skeletal muscles to protect your bones. And also, strength training has been proven an effective tool to maintain your telomere length. So, yes, strength training. And also, if you're talking about, I'll go into that later. It's in depth on telomere length. And then sleep. Sleep, we know that it repairs cells and prevents cognitive decline. We talk about brain a lot when you're talking about sleep, but sleep also helps with rest of your organs because your heart slows down, your lungs slows down, everything slows down when you're sleeping. So they have rest, and those cells in those organs have time to repair, and they will not be exhausted if you give them plenty rest. And then supplements. I mentioned supplements when we're talking about dysfunctional mitochondria. So there are supplements for different, and there are so many emerging longevity molecules. So NMN is one of those. It's a molecule that is naturally produced in body, but as you grow old, that production declines, you can take those supplements. Most of the supplements, you need to take them because you can't get them from food. There's many like that you can't get them from food. For example, omega-3, you can get them only with certain food. There are very few food items that you can eat, you can get omega-3 from. And there are people, for example, vegetarian, they have very few options to get omega-3. So it's very important for them to get supplements. And then stress management. So I would like to, there are many books actually, there's one particular books on telomere length. I will forward it to Gabriel. So if anybody interested, they can have a look through. It's for general public, and it's actually written by a psychologist and geneticist. So they bring together all the science on telomere length and how both your genetic makeup and your stress, physical and mental stress, is affecting your telomere length. They've done all sorts of studies on different types of organisms and on human beings. So stress plays a significant role on your aging process. And social connection. We are a social creatures, and it's very important. The hormones that are released, the biochemical reactions that are initiated when we have a social interaction is very important for our aging process. And that can also, there has been studies where old age homes and daycare centers, they bring them together, and then they have done those studies in those elderly people, how their aging process has improved significantly because of those interactions. So if I have to, I have very little time. I see I have crossed my time actually.
Yes,
So
yes, Nikita, we need to get to the Q&A
questions.
session.
Yes, I see there are
And
many
there's many
questions as well.
questions. Yes,
Yeah.
absolutely.
Okay, yeah, I'll start. We can start the
Okay.
questions. Yes.
Okay. It's very fascinating. So I understand how difficult it is to put everything into 30 minutes.
I know.
So okay, so let's get to the questions. Thank you everyone for asking the other questions in the chat. So the first one comes from Anthony, and his question is: if telomere length is important to monitor, which cells do we monitor, or do we just monitor those that are the most easily accessed?
Yes, so that particular study has been done multiple times in different ethnicity as well. They have compared the blood cells, skin cells, saliva, and they have realized that obviously there'll be difference in the telomere length because the number of times your skin cells divide and the number of times your blood cells divide will be different. So it's better to avoid a very fast dividing cells like skin cells because they are much older than you say your buccal swabs or cells, buccal cells or your blood cells. But the cells in your body, you can measure any of those. Like generally blood, whole blood cells or buccal cells, buccal cavity cells are very often used, even sometimes saliva as well. But it's better to avoid skin cells or fast dividing cells. So there'll be slight difference, but if you are comparing, if the database that you're comparing with is the same, for example, saliva, all of them are saliva, then you will get more accurate results. All the database has whole blood cells, you'll get accurate results. But skin cells you won't, because if you're a more outdoorsy person, your skin cells will have divided much, much faster than someone who is always indoors. So it can't really be compared that easily.
Okay, interesting. Another question coming from Jenny, very deep question. Thank you, Jenny, as I happen to know you from other meetings. So her question is, can we get a sense of our DNA not operating optimally, like intuitively, by intuition? And if it has been studied, are there any connection on what's happening between aging and energy in other ancient wisdom health systems?
Yeah, I can't talk about ancient wisdom, the health systems, but yes, you can get sense. I won't talk about like not how your DNA is operating optimally or not, but whether your cells are cell health. So they are connected, but they're not the same thing. You can get a feeling about your cell health, which is basically like if you're always if you can focus on a one particular system, organ system, like your digestive system or your neural system, they're easy to focus on compared to other systems, right? For example, if you were able to have a hearty meal like a year ago, and now it's very difficult to digest, right? Sudden changes, very significant changes. Or you used to have a lot of energy, and suddenly during the day you have energy fluctuation. So those kind of things you can, those are not something that those are not things that something you'll go to a doctor for, but you can look into your vitamin profile. If you don't want to go into biomarkers, you can start with those, your vitamin profile. If is there something that your body is lacking, right? Because maybe suddenly your body stopped producing or reduced that production. And those things can be easily based on how the extent of your what that profile is saying and your age. You can easily make up for it based on different slight lifestyle changes or nutrition changes. For example, you don't have we like for women, they start having iron deficient as they grow older, right? So maybe last year that is one of the, when you check your energy, you find the energy fluctuation. That is one of the most common things they find, iron deficiency. So you can start taking iron supplements or ads, because at that time, if you're finding iron deficiency, adding, changing your nutrition won't help because it won't be enough. So you would need iron supplements. So it all depends on the extent. So that's why quantification is so important. You would think that I'm having spinach, so maybe that's enough. But if you are iron deficient, having spinach won't be enough for you. But if you're doing it continuously from the beginning, so that you don't have significant changes in your energy levels or your digestive capacity, then nutrition will be enough. So it all depends on the extent to which. So that's why quantification is very important. And also,
Yeah,
uh,
agreed.
how she mentioned about energy flows, right? So if you're talking about frustrations and feelings and all those things, that also does affect significantly. If you had a significant traumatic or stressful event, okay, or something coming up and you're stressful about it, it will have significant effect on your telomere length. The cells are dividing every day, right? That happens fast. It's not, if it is significant enough, it will happen within a month. So that time you can look into all these things, like what exactly is happening. First, you can have an introspection. What is the changes that's happening? Journaling also can help. If you're, before you go to actual biological analysis, you can do all those kind of analysis by journaling symptoms, like what exactly is happening to you. And is it because of mental uh, mental circumstances, or is something because your mental stress can also affect your physical condition. So you need to find the root cause and then the symptoms, and then you can work on both of them.
Okay. Next question comes from Anthony Bartlett, but Anthony, maybe you can ask your questions because it's highly technical. I prefer not to modify it too dramatically.
Yeah, you mentioned earlier that it's important to look at genetics from a genetic stability perspective. Maybe it's a bit of an unfair question because I work in the omics space, but it seems to me now that the measurement of protein levels, you might want to call it expression, but it might be something else, but protein levels, it's now possible to measure thousands of proteins at once in plasma or serum, and you can glean from that signatures which are associated with the hallmarks of aging, of biological as opposed to chronological aging. And my question there is there an opportunity to create almost a community database where people are tested for their proteomic signatures and then look at how that is correlated with improved or worsening health from the hallmarks perspective? I don't think there is any
Yeah,
such community
yeah, it is.
database, but is there something that we could build here? And then start to look at this not from the perspective of intervention, monitoring the interventional outputs of pharmacological agents, but more looking at lifestyle interventions, which I don't think anyone is really looking at hard. There's no financial incentive, but there is probably within an interest group such as this. So that was
Yeah,
the basis.
yeah,
The
yeah.
tools
That's a
are
very
there, but they're not
good.
being deployed in a way unless it's financially motivated by a profit-seeking pharma company. But is there another way of pushing for the
Yes.
development of such a tool?
Yeah. So that's a very good question. And that's what I was saying, that I think that, we should not only focus on genomic, we should focus on proteomic as well. Actually, all the omics, there's metabolomic, and then this transcriptomic. So all
Yeah.
these things tell you different information. And proteomics is so important because it tells you relative information. The proteomic that you have right now, the proteomic profile of yours right now might be completely different than 5 years ago. But your genomic profile will be mostly similar. It won't be that different, right? Genomic changes would be mostly just because of epigenetic changes and the telomere length. But proteomic, it gives you so much information and useful information. The only thing is, like you mentioned, it's expensive. But there are ways to do, people are working on it to do it mostly in-house. If you do mostly in-house, if you standardize things, because aging is, we're still in the process of learning. The cancer, we know so much information. That's why we know what to do. So that's why everybody is working on the therapies and treatments. But aging, we're doing it simultaneously. So we know these are the set of protein that we want to, make a panel or something and then measure them. And then meanwhile, we're coming across more proteins that are involved in aging. So it's going simultaneously. But it is gaining traction. There are many startups out there, many companies who are trying to make it cheaper and more standardized and generalized. But then again, the challenge is aging is very personal. It's unique. Aging process is very unique. So we have to be very careful of that boundary of standardizing to make it cheaper and more accessible, but also keep it more personal. So we are working on it. And it's very nice to know that people are actually interested in that and want to, be involved in it.
Yeah, and I think an extension of that question is, are you also considering things like metabolomics from as a proxy for the microbiome? And I think that's also highly personalized. But again, if we can build a community database, a community test results package that we can compare ourselves, that's something that, maybe you can help engineer.
Yes, yes. Yeah, we would love that. We are working on those things. Yeah. Yeah, it will take some time. And also that the relevance of the database, we'll have to have, unlike genomic, we can't just have one database. We'll have to have different database for different specific communities and also a different timeline. Because it, like I said, proteomics, metabolomics, they are all relative to time. They change very drastically. So when we have those kind of databases, we need to have much extensive database compared to genomic.
Yeah.
So yeah, it's happening.
Thank you.
Okay, next question, and maybe one of the last ones, coming from Tamara. What about antioxidants and reducing inflammation? I suppose the relationship between both. Maybe Tamara, you can elaborate if you're here. Whatever. Yes, Nikita, please.
Of course,
No, Tamara.
Okay, I can do it if you want, no problem.
Yes, please.
I thank you, first of all, for the presentation. I really, really enjoyed. I really like this topic. And you were talking about ways to help to reduce aging, and ways that we can do not only by changing our habits, but also about supplementation. That's why I'm asking about, what do you think about antioxidants and the relation with reducing the inflammation and to help to reduce, the timing of this aging inside the cells?
Yes.
Thank you.
Yes. Very good question. Actually, I was about to talk about it, but then I crossed my time limit. So antioxidants are very, it's a key factor in when it comes to dealing with aging or cancer, because when cells divide, it produces, throughout its lifetime, it produces something called oxygen-free radicals. Every time we breathe oxygen, we have oxygen-free radicals, which causes all sorts of damage, including DNA damage, and then which can lead to cancer and then obviously aging. So antioxidants are useful. Antioxidants basically deal with those free radicals, right? So they are already established to play a significant role in addressing many of those hallmarks. One of them is, like you said, inflammation. It helps with inflammation, and it also helps with maintaining the telomere length. And there are many sources of antioxidants, like green tea, apple, all different types of berries. And let me just see. Yes, dark chocolate, spinach, legumes, seaweeds. So there are many different sources of antioxidants, which are rich in antioxidants, and you can have them every day, right? And that's not like, that can be a part of your lifestyle, regardless of what specific aging process that you have. And also, there is dietary, high intake of dietary fiber is also has a protective role in telomere length. And this antioxidant also protects telomere length. And you mentioned inflammation, right? So in addition to inflammation, in addition to antioxidant, sleep also plays a significant role in inflammation. I mentioned earlier that sleep is when your cells repair and clean themselves, right? Take out all the toxins and everything. So when you don't get enough sleep, your cells don't have enough time to do that, thus causing inflammation. So fasting is another way, intermittent fasting is another way people reduce inflammation, but it won't work with everybody. But sleep and having antioxidant rich nutrients will work for everybody. Yes.
Yeah, we still have a couple of minutes, and I would like to ask also one question I had from the starting point. I've done this true diagnostic test, right, which gives you the biological age and your fitness age and all sorts of very interesting things. And one of those things is the telomere length. I happen to have telomere length equivalent to a 52 years old individual. And I'm 43. And when I've done the test, I was 42. So my question is, I mean, the interpretation I give to this is that I had a very stressful life as an entrepreneur, and I always wanted to push myself beyond my limits, and I sort of got over my age because of that. But now that things are as they are for me, what kind of treatment do you recommend to get that sort of length back and to have a better biomarker when it comes to telomeres?
Yeah. So telomere length is not something you can, it won't be treatment per se, but I can recommend you some things. For example, sleep. If you can't get a duration of sleep, focus on quality of sleep. Because of lack of time, you might not get the chance to sleep 7 to 8 hours or 9 hours. Then you can focus on very good quality 6 hours of sleep. It's very important. Second is if you can't if you can't have your meals in time, then you can focus on, again, if you can't get quantity, focus on quality. So you can focus on antioxidant rich food every day, something that has rich antioxidants. If you don't like having green tea every day, then maybe berries. You can have different berries every day, something. And always keep a variety in your food, in your exercise, whatever you do, keep variety. And what else can I say? Of course, high dietary fiber. Yes?
Yeah. Is there any sort of supplement that sort of activates the telomerase so that it lengthens your telomeres?
As per my understanding, there are no specific supplement that can target directly your telomere, but it can target additional things. Like there are supplements that can, calming supplements. There are supplements that can reduce the free, like basically supplements for antioxidant, anti-inflammatory. So all those things will around the telomere length. It will help telomere length, but it's not directly affecting telomere length. Because it's something, stress is very significantly affected. That's not like,
Yes.
you can't have a pill and be stressed whole day. So that pill won't really do much. So it's like at some point you need to have some sort of rest. both for your body and for your brain. So you need, and for your mental health. So you need some sort of rest. Only those kind of things can help your telomere. But then there are some things that are already proven to help your telomere length, like strength training exercise. They're significantly proven. And social interaction. For example, if you're meeting your friends once a week, like completely just living in the moment, kind of once a week for 1 hour, that can help your telomere length significantly.
Okay.
So, but you need to keep switching it about, and you can always check again after you follow all these recommendations. You can always check maybe in a year or so and see if there's any difference.
Yeah.
And also, the number that you're getting, it's an estimate based on the database they have. So you also need to see what did you give for your telomere length, what samples you gave for your telomere length, and where did you get the test done? What is the kind of database they have? So it depends on a lot of things, because aging is very personal and it's also very relative. How we understand is it's very relative. What is happening to you is very personal. So when we, as scientists working on it, we need that line of generalizing and personalizing. Similarly, you as a customer getting that information, you also need that line of generalizing and personalizing.
Yeah, I think it's a very nice conclusion, and time running up. So I think running out, sorry. So I think we need to wrap up. Thank you very much, Nikita, for the presentation. Very useful, lots of questions. Some of them we weren't able to give them the attention they deserved. But yes, we still have the Slack workspace, and you guys can reach out to each other, to Nikita also at any time. And by LinkedIn also. So thank you very much, everyone, and see you in during for our next session in
Thank
a
you so
couple of
much.
weeks. Oh yes, the Slack workspace. Okay, so that's I'm sharing right here. Ikare.ai. Just let me make sure that I have the right URL. Yes, so you have it here. Let me type it. Okay, so this is the URL, and you sign up. It's 100% free, and you have access to lots of resources. You have access to the whole list of workshops we've had, and many other things, and also the workspace. So please go ahead and sign up and join us. Thank you very much, everyone. Again, I
Do
have
reach
to
out to
go.
me in LinkedIn.
You
I'm
too.
happy to answer any questions.
Yes. Yes. Thank you, Nikita, again. Bye bye. Have a great day.
Bye.
Bye.